So this is our bridge course day 11, and today's class is going to be very special because of a very special topic. In today's class I am going to explain about functions. So in mathematics of 11th 12th class we used to have our function chapter. There we used to deal with our domain and range. Okay, so I will take the class. Here I will discuss different types of functions and how to find out their domains, and we will continue the chapter. So see here, whatever we have taken, like all the 10 days classes. So in that if you go to bridge course and then you go to your video lectures, all the last 10 lectures are there. If you have not completed, then you complete them, and all the DPPs are there, you solve them, and whatever doubts you have, you ask those doubts. Okay, and okay, so let's start this. So we have to start from a very important topic, function. So actually when we talk about function, we used to have function symbol like this, like fx is equal to some x square plus 2. Sometimes we write y is equal to fx. What does it mean? Meaning is we are using two variables in this also and two variables in this also. Okay, here in this total fx is giving you idea that this f is any function. To define that function we need some variable, so I am using x as variable. Okay, now what kind of function this f is, you can clearly see here you have a square. So a square is actually a function. Then here you have plus sign, that is also as a function. Okay, but in this, what is difference between this and this? So in this I am using another variable. This variable is defined through this function, that function fx will be giving you another variable, this y. So we got two variables, one is y, one is x. Y is actually, you might have heard in your basic classes, there is something called dependent and independent. Already in previous few classes I have explained this part. So this x is known as independent function, independent variable, and this y depends on this x through the function f. So this y became your dependent variable. For example, if I am writing y is equal to sine x. Okay, now let's compare this as this with y is equal to fx. Okay, so this y and this y, they are same. Here I am using a variable, so that variable is here. What is this function? This function became sine x. I can also compare like y is equal to log x, right? So this f is your log. Actually what happens in GATE preparation, when you prepare for GATE exam, then in your core subject, like we only jump to our core topics. We don't bother that you don't know basics, you know basics, what is your level. That's why this bridge course is important, because I am going into very deep and detail for every single bit, because when you are solving a higher problem, then you should know the basics in very detail. Like for example, suppose just an example, you are preparing, you are BTech qualified and you are preparing for GATE exam, or you are in third year or final year, you are preparing for GATE exam, and in your family or some cousin or someone is in 11th class or 12th class. He or she will be impressed that okay, my cousin, elder one is preparing for GATE exam, so let's ask this question to the person. Okay, so he or she will may ask some function, some question, something like this. You may not be able to reply. So see, I am not expecting that you should be able to reply everything of your 11th and 12th class, but you should be able to reply at least that much what you are going to cover in your GATE syllabus. Okay, so function is one of them. Okay, so see, there is something called function and there is something called equation. Function and equation, they both are different. If I am writing fx is equal to sine x, this I can write. Okay, so this fx is equal to sine x, this became your function. Here I am defining that I am using a function sine. Sine is a function. Which function? Trigonometry function. But if I am writing equation, then I will write equation, suppose sine x plus 2 is equal to 0. So see, this is how your equation and function, they are different. Okay, in case of function, in case of function, you will be having its domain, its range, right? Domain and range are defined for a particular function. In case of equation, you will be having some set of values which will satisfy the equation. Okay, those values we call as roots. Okay, we call as roots. So this is the difference between equation and function. Okay, anyway, we'll go ahead. See here. Our target is to understand function. So if I'm defining any function like y is equal to fx. Suppose, for example, I am taking example of y is equal to x square. In this, this x is your independent variable and this y is your dependent variable. Okay, so this x is playing the same role like here. So this is your independent variable and this y is your dependent variable. Why your y is dependent variable? Because y depends on x. If you change the value of x, y value will change, right? Reverse you cannot do. Math will not allow you. Okay, there is something called inverse functions, but that particular thing we are not going to cover in our bridge course syllabus, because bridge course syllabus is especially for GATE Aerospace department right here. Okay, whatever is important for GATE Aerospace, only those topics we are taking into detail. See here, this square is actually the function. Okay, now whenever you have function, whenever I am writing any number here, how will you know that this function exists in mathematics or not? This function exists in real life or not? Okay, for example, for every country we have different currencies. For example, for India we have rupees, then we have dollar or something, we have euro and all we have, right? Suppose like you are thinking you are going to print your own currency. Now, okay, suppose my name is Vikas. I am keeping my own currency and I am putting like this is my currency symbol. So I printed my own currency and I said 20V, some amount I am saying, and this money I am going to take market. So market will not accept this. Means if I will write anything, x square minus 2 plus 3 plus, like if I will write anything, this thing has to be a function. I mean this thing has to be a valid function, because in mathematics anything you cannot write anything, right? Whatever you are writing, that should be a defined function. So how will you define any function? Okay, but actually now like right now whatever if I'll say create any function, then you can create any function. You can say sir, y is equal to sin x plus log x I am creating. So I am saying this is a valid function. How can you say this is a valid function, right? So for that we have a small trick. Whenever you are defining any function with two variables like y is equal to fx, there is a condition. This function will exist if and only if you draw graph for this fx. Just an example, I am drawing this graph. Okay, now you want to check this function exists or not. So for that what will you do? You draw a line which is parallel to y-axis. This is your x-axis. If this parallel line is cutting graph at only one point, then you will say this function exists. But imagine if I am drawing a graph like this. Okay, just imagine this is also my y is equal to fx graph, this is also my y is equal to fx graph. Two different cases I am considering so that I can give you contrast that which is function, which is not a function. So you can see here this is being cut at two intersection points are there. That's why the green line is not possible a function. So this green line is not going to be a function. Only red line is a function. Why this green line is not a function? Why? Let's understand this. See, if I am saying y is equal to fx, for example, y is equal to x square. Okay. Now, if I will substitute here x is equal to 1, then suppose I am getting any value, that is y is equal to 1. Now if I will substitute x is equal to 1 again, then do you think I'll be getting y is equal to not 1? See, focus here what I'm trying to say. Suppose at any time I substituted, or any student is substituting x is equal to 1 and the person is getting y is equal to 1 as the answer. Some other student is substituting x equal to 1, but he is not getting y is equal to 1. Suppose he is getting y is equal to something else. Suppose he is getting minus 7. Okay, so this particular scene, you will definitely say, sir, either this answer is wrong, either this answer is wrong, or both is wrong, or both are wrong, correct? Because it is not possible that you will justify this is also correct, this is also correct. Let's understand that by the graph. I said, imagine this function is actually this function, and suppose this is the point where you have x is equal to 1. So at x is equal to 1, if you draw a line like this, so this line will give you two intersect. One is here. So this intersect I am saying y is equal to 1, and one is here. This is I am saying y is equal to minus 7. Is it possible? No, this is not possible. That's what I said. You have to draw a line and you check. So draw a vertical line. Vertical line means parallel to y axis, and you check. It is getting two intersection. More than one you should not get. But here we are getting. It means this graph does not exist. I mean, this is not a function. Graph wise you can draw anything, does not matter. But that should be a function. Then only you can deal with the function in mathematics, right? It should exist, whatever this is. This should exist. This should be fit in the mathematic rules like domain and range. So actually, in the beginning, you should know any given thing is function or not. So this we don't have to check for GATE exam. Okay. Now next thing, if you know that any given thing is a function, then what are you going to do with that information? Then if you know if something is function which is existing properly, there is no error in the function, then your job is to know what is the domain of the function. Okay. And what is the range of the function. In GATE exam, they will not ask you domain directly. In GATE exam, they will not ask you range directly. No, direct questions will not be there for domain and range. But every year I can show you one question where concept of function is being used very properly. And if a student is really very good in 11th and 12th class, no need to do this bridge course program, and he or she can directly hit that question as right answer. Okay. Like if I talk about 2022 exam, here itself we had 3 questions from basics. That's why bridge course is mandatory. Okay. And these 3 questions, what I'm saying, this actually we don't discuss at university level. No one will teach you at university level. They all will complete partial differential equation, vector calculus, and blah blah things, whatever is assigned in the university and GATE syllabus. But basics they can ask, because they know that you have cleared your 11th and 12th exams. That's why they have freedom. They can do this. They can ask this. Okay. Now see, our job is to skip all these basic informations and to jump how to calculate domain. So I will teach you some very good conceptual questions so that you can be easily find out domain for the remaining questions. So I have selected some very good problems and we will learn how to find out domain for them. So, but before that you should understand what is domain. So see, y is equal to fx. Just take an example. Y is equal to log x minus 1. Now see here. You should know the log function in detail. So already log topic I have covered in previous lectures. Now see, what is log? That I am not going to discuss. But whatever is in front of log, that should be positive value, then only this function will be defined. If this value should be a positive value, then you cannot put here x is equal to 0.5. If you will put here x is equal to 0.5, then automatically this total answer will become negative. And log will not accept negative values in front of this. Right? So this value, what you can assign here, those values are known as domain. So from where will you bring your domain? Entire values, whatever is available in mathematics, that we club as a real number R. Okay, we say that all my numbers are fit into R. From R, you can pick root 3 also, pi also, e also, 1 by 2 also, minus 1 by 4 also, like all the possible values in mathematics, you can pick from R. So, can you say in this particular case, can you say x value is going to be R? Or your x belong to the complete R? No. Why? Because just now I have shown you that you cannot substitute x is equal to 0.5, because if you substitute x is equal to 0.5, this guy will become negative. It means you have to know how to find out those values what are suitable to substitute here. Correct. In that case, we should follow some procedures, because in different cases, if I'll change this function to sine function, tan function, cos function, root, so in different cases, your concept will be same. Your rule to find out domain will change. Okay, so let's understand one by one. So see, first you have some basic rules, and after that some additional rules are there. They will change with function to function. For logarithmic function different, for exponential function different, from trigonometric. So first we go for some pet basic rules. So first of all, whenever you have a square root, inside the square root you can be 0 or you can be positive numbers. So technically, if I say inside the root, whatever number you are writing, this must be greater or is equal to 0. Okay, it can be 0, it can be equal to 0. Inside the root you cannot have negative numbers. Okay, so this will be a hint for you. With this hint you will calculate the domain. So this is one thing. Now next thing, if you have a denominator value, for example, this is your numerator and this is your denominator. So denominator can never be 0. Okay, can never be 0. Don't worry, don't be confused. I am not saying for 0 by 0 concept. I am not saying for infinite. No. I am not taking you here. I am simply saying denominator cannot be 0. Correct. So this will give you another set. Okay, so suppose if I will combine this and this together, then third point, suppose I have 1 by under root x minus 1. For this question I am looking for the domain. So in this question, your x location is inside the root also, and your x location is in denominator also. So both rules you have to follow. So let's solve this question. But before going to this question, these are two very basic and important rules. Before going to this question, I am giving you two more rules. One more rule. Suppose you know for y is equal to fx, you got a set of answers as a domain D1. Suppose you got another answer, another question, another function as y is equal to gx. For this also you got any domain D2. Now you are combining these two functions and making a third function. Like see here, I use this and I made a third question. Okay, so if you combine these two functions, then how their domains will behave. So this type of question directly they will not ask in GATE exam. Okay, but if you know the idea, then there will be some questions you can crack. Now I am going to explain if you will add or subtract these two functions, like y is equal to, I'm framing a new question. Suppose or directly I'm writing, if you want to add fx with gx plus minus, in that case, or if you are going to multiply, I'm getting some space here, or if you are going to multiply like fx into gx, in both the cases your intersection of both the domains will be your new domain. Means d1 intersection d2 will be your new domain for this guy also and for this guy also. Okay, now let's understand this with the help of this example. Okay, and if, okay, just take the example. Your example is very easy, 1 by under root x minus 1, and how to find out domain for this function. So you understood what is the domain meaning. Meaning is what are the values I can substitute here so that I will be getting a good answer. Good answer means real answer, which is mathematically possible answer. Okay, so you have two conditions. First condition, your denominator should not be 0. You have next condition, inside the root whatever is written, everything should be greater or is equal to 0. Okay, so see, because it is in denominator, so denominator part cannot be 0, right? So this equal sign you will remove. It means this inside whatever is there, this should go for only one condition, more than 0. So x more than 1. So this total became your correct answer. It means on your line number you have 0 here, you have minus infinite here, you have plus infinite here. So here somewhere you have 1. Okay, so all the numbers which is more than 1 is your domain. I mean these numbers, all numbers more than 1 is defined as a domain for this. For example, can you substitute x is equal to 0 here? No. Why? Because if you substitute x is equal to 0, then entire root will become negative. So no, root is not defined for negative. For negative answers, for example, minus 4, you cannot find out a square root. Okay, that is different, that sir answer will come in complex number. No, we don't have to go in that way. Okay, clear. And what if can I substitute here x is equal to 3? Let's check. So yes, substitute here x is equal to 3. So if you are substituting x is equal to 3, are you getting the right answer? Yes, we are getting positive answer, no problem. That is real number. Okay, so after substituting your domain, whatever answer you are getting, that is known as your range. Okay, so now we'll take another question. Log x square plus 2x plus 1. Now see, this is my new question. So you just add in your info, because I am changing the function now. So whenever you have log and whatever is in front of the log, so consider that is x. This entire value cannot be negative, it cannot be 0. So this value, whatever is written just example x, that should be greater than 0 always. So this total answer should be greater than 0 according to the condition of log. Okay, to calculate your domain. So x square plus 2x plus 1 must be greater than 0. You should not put equal sign in hurry. No, 0 is not allowed in front of log. Correct? So x square plus 2x plus 1. How will you break this? So for this, I hope you understand very clearly that this is nothing but x plus 1 whole square is equal to greater than 0. Okay, it means what? Any number you have to substitute in such a way that this should always be greater than 0. But problem is, how will you find out the range, the location? Like how will you know, okay, which number is comfortable, which number is not comfortable? So understand, this x plus 1 whole square, this x, can you substitute any negative number? Yes. Why can you substitute any negative number? If you substitute any negative number, then that negative number, for example, if can you substitute minus 100? Yes, I can substitute minus 100. So I am giving you a trick. Trick is very good trick. Inside the bracket, whatever is written, so just next to the x, whatever number is written, that number will help you to find out critical point. What is critical point? Like this is x plus 1, right? So you go for x minus 1. I mean x equal to minus 1. X is equal to minus 1 can make this number 0. X is equal to minus 1 can make this number 0. But 0 we don't have to take because we have to take greater numbers. So now we will check how I am getting x equal to minus 1. X equal to minus 1 I am getting because this minus 1 if I substitute here, then I will be getting 0, but which is not allowed. So on line number you put here minus 1, and now below minus 1 you cross check any value. If that value is satisfied, then all the values will be satisfied. In same way, for more than minus 1 also you choose any value and substitute, and if any one value will satisfy, all the values will satisfy your domain. Okay, let's understand this part. So I am choosing any number here. Suppose choose minus 1000. You can choose any number, feel free. You can choose minus 3 also. So substitute here minus 3. So what are you getting? Minus 3 plus 1, you are getting minus 2, but because of whole square it become plus 4. So plus 4 is more than 0. Yes, it's correct. It means below minus 1 I can choose any value. So below minus 1 till where will you go? You will go till minus infinite, but always remember minus infinite and plus infinite we never choose. Okay, so once you are sure from where to where you are able to choose, then you see this is your minus 1 and this is your minus infinite, this is your plus infinite. So from minus infinite to this minus 1 you can choose all the values. Okay, so your answer will be minus infinite comma 1, and I am putting open bracket. Why? These bracket cases I have already explained in the previous classes. then you choose more than -1. So for more than -1, which value I can choose? For testing purpose, you can choose any value. You can choose 100, you can choose 5, you can choose 7.9, any number you can choose, but it should be more than -1. 0 also you can choose, because that is also more than -1. Okay, so in this, let me erase this part. In this, when you choose x is equal to suppose 0 I am choosing. So is this total answer is coming more than 0? Yes, it is coming more than 0. So you got that more than -1 is also correct for us. So you again put open bracket till here. Okay, so you got two brackets. Sorry, here I should write -1. Again you write -1 to infinite. Open bracket, open bracket. You got one set here, you got one set here, but because both sets are possible, so you put union. Okay, but can you choose x is equal to -1? I mean the critical point itself, can you choose? No, we cannot choose -1. Why can't we choose -1? Because if you will choose x is equal to -1, then this bracket will become 0, and we are not looking for 0, because in front of log 0 is not defined. We are only looking for more than 0. So this -1 you cannot take. That's why I have not used closed interval here or here. Okay, so this total became your right domain, right set of domain. This answer you can also write like r minus remove this -1. I mean entire answer we are taking from the r. We are only not taking -1. I hope it's clear. Now let's do one more example where log and square root both will be connected. If same answer, if same question, I will put for log bracket x square plus 2x plus 1. Okay, this is one question. And another question, log under root x square plus 2x plus 1. See the difference in both the questions. Okay, if log is defined for anything, then automatically root will be defined for that, because before the root log is a trouble. I am talking about the first question, this here. So whatever we have solved this, we have got the answer that r minus -1, this total is my set of domain. So this answer is satisfied for this x and this x. So log is satisfied. Log will never give you answer where you are going to get negative. Is it so? Can log give you that answer where you can go negative? Log will give you answer, and that answer will be negative only in one case. You tell me guys, in which case log will give you negative answer? I have taught you in previous lectures. Tell me. Yes. Yes, you're audible. Yes, you're audible. I heard your answer. That is absolutely correct answer. Yeah, absolutely correct answer. So see my explanation. Yes, you are absolutely right. It means what? See, when I was explaining log x square plus 2x plus 1, here we only considered that in front of log, here only positive number should appear. Because of that we had our condition. But remember, this positive number here can be negative also. Can be in decimal also. For example, decimal 0.5. So log gives negative answers when log is having decimal here. Correct? It means if this total answer will start coming as negative answer, then root condition you have to apply. Root says no. Inside the root, negative is not allowed. It means what? We have to check one more condition, that for which condition this total x square plus 2x plus 1 can be negative, can go decimal. So that answer is, if your x square plus 2x plus 1 is more than 0 but less than 1, then only we have problem. Okay, less than 1 means, can I put here like this? Can I put here equal to 1? For equal to 1, I don't have any problem. That's why I'm not putting, because if this total answer will go equal to 1, then log 1 is equal to 0, and for 0 root is defined. So that's why I'm not putting equal sign here. So now with this condition, I will find my separate set values, and with this condition, I will find my separate set of values. Okay, and in that, whatever will be the common answer, that will be my right set of domain for this question. Let's do that. Means whatever is remaining job, that is only solve for this and solve for this. So in these type of problems, you will understand inequality also, how to solve inequalities. So for this, I am taking a new page. So first I will solve x square plus 2x plus 1 greater than 0. So for my convenient, this greater than 0, I am writing like this. Okay, just for my handwriting purpose. It gives me psychological freedom. That's all, nothing else. Now see what I'm going to do. There is no difference. This is also same thing and this is also same thing. So don't worry. Now, like sometimes what happens? Sometimes, in childhood we used to calculate 2 is equal to x. Then we used to write x is equal to 2. So that part I'm doing here. So now next part. X square plus 2x plus 1 you can write as x plus 1 whole square greater than 0. So for this you will apply. Now you are looking for greater than 0. So which value you can substitute here to get greater than 0 values? To get greater than 0 values. So greater than 0. Exactly you are going to find out your critical point, that is x equal to minus 1. So substitute this is minus 1. So below minus 1 whatever answer is done you will find out, and above minus 1 whatever answer is done you will find out. So for this only, but exactly minus 1 you cannot do. So for this only we calculated that here below minus 1 is done as my answer, and here above minus 1 is done as my answer. Now let's go for another set. In another set we have to find out x square plus 2x plus 1. This should be less than 1, correct? And if you write like this x plus 1, okay, we can do one thing. This one I can take left side. So this one and this one I can cancel. So I'm going to write x square plus 2x less than 0. No doubt here. Then I can take x common. So x common. So x plus 2 less than 0. So this is giving me critical point x is equal to 0, and this is giving me critical point x is equal to minus 2. Minus 2. Okay. So now minus 2 is here and 0 is here. So for this interval and this interval and for this interval, I will look for my answer. So very easy. Below minus 2 you check. So you can choose any bigger number. Any bigger number means suppose minus 1000. So minus 1000 means this part will be negative and this part will also be negative. So negative and negative, if you multiply, you got positive. So positive answer is less than 0. No, it is more than 0. So this interval you cannot choose. So there is a trick. If this interval you cannot choose, this you will choose and this you will not choose automatically. Okay, so let's find out for this. Between minus 2 and 0 you have one answer. Suppose I am choosing a number as minus 1.5. So whether minus 1.5 will satisfy or not. So here you put minus 1.5, so it is negative. Here you put minus 1.5, so it is 0.5, so it is positive. So negative and positive you multiply, you are getting less than 0. So that's why this interval is satisfied. But in this interval you are getting minus 1 also. And just now we have seen that minus 1 we cannot choose. It means what? Now you see the line number. In my line number, I have now for this concept and for this concept I am going to combine my line number. So minus 2 here and minus 1 here and 0 here. Okay. So minus 2 and 0 because of this set, and minus 1 is because of this. So see, below minus 2 is restricted because of this condition, and above 0 is restricted because of this condition. So whatever answer I have to think, I have to think only in this gap. So in this gap, only this minus 1 I cannot choose and remaining answer I can choose. Very simple. So my answer is going to be minus 2 to minus 1 union minus 1 to 0. That's all. Now one more thing. Can I choose 0? Can I choose minus 2? So for these two conditions, equal sign should be there in your inequalities. But I don't have equal sign. That's why I'm not choosing closed interval. Right? So this question over. Now we'll talk about another question. Now I'm choosing this question, log under root x square plus 2x plus 1. Now in this question I'm going to understand how to think about domain of the function. So see, this under root says, see, can under root give you plus or minus answer? That is one thing. Next thing, inside the root, what is the condition? So x square plus 2x plus 1, you have to think only for greater than or equal to 0 because of under root. But x square plus 2x plus 1 greater than 0, we will choose. I cannot choose this equal sign. Why? Because if this guy will become 0, then this entire root will become 0, and in front of log 0 is not defined. So I will choose for this. So if you are choosing for this, what kind of answer you are going to get? Now this is one thing. Now next thing. Okay, this part you have done, and you know that you will be getting -1 as your critical point, and below -1 everything is valid, and after -1 everything is valid. See, log, suppose I am getting log under root 4. So do you think this log under root 4 will be valid for me? Just an example. I mean to say, log this under root 4 can give you two answers. This under root 4 can give you plus 2 also, and it can give you minus 2 also. And in front of log, only positive answers are valid. So you have to say, in this total answer, from minus infinite to -1, you can take your domain. Union from -1 to infinite, again you can take your domain. So suppose if I am choosing any domain in between, suppose I am choosing, so okay, this is the answer. First of all, this is the answer. Now, but just cross check if I am getting any domain that is satisfying or not. You just choose 50. So substitute here 50. 50 is from this side. So substitute here 50. Will you be getting positive answer? Yes, I'll be getting positive answer. So if I'm putting positive answer here, will it be okay? Yes, of course it is okay. Okay, it's totally clear that okay, this will work. Now, what root is giving you, that is different scenario. That is different scenario. This thing is clear that okay, I am going to get root 50. But here we will choose in one more way. I'll tell you what I'm going to choose. In front of log you have under root x square plus 2x plus 1. Log says in front of me, okay, meeting was over, so now we are joining again. So see here. So in front of log, whatever is there, that should be more than 0. If this condition you will apply in the beginning itself, then you will not do mistake. So you apply condition that x square plus 2x plus 1 should be more than 0. That's all. So you solve for this equation. Now you understand one logic. In mathematics, you have some tricky points. Mostly we don't understand that point. We do mistake in hurry burry under function chapter. See here. If I am writing -3 is less than -2. Sometimes actually what happens, students write that x is suppose x is less than y, then if I square both sides, x square and y square, so they think that even this will be less than y. These small points are from inequality topic. So if students are not good in inequality, they can do a silly mistake in GATE exam. Right, in my example you see -3 is less than -2, but if I'll square both sides, so I'll be getting 9 and 4. This time you cannot write less sign, correct? You understand why? So that's why squaring and writing like this is not allowed under inequality. That's why we don't get the right answer. So what we have to do, but one thing is very sure, if something is greater than 0, then definitely that is going to be a number, a positive number. For example, if I am already very sure that, suppose I am writing 5, which is more than 0. So if this I will square, then automatically 25 will be more than 0. But here inequality allows you, because it is logically correct. So I have something inside the root like here, and because of log I am putting condition it should be greater than 0. Then automatically if I will square both sides, like square here also, square here also, automatically it will be correct. So x square plus 2x plus 1 also should be greater than 0. Now because this I am getting from this and this I am getting from this logic, so whatever inequality I'll be getting for this, that will be your right domain. So this question already we have solved. Okay, now we'll go ahead with another questions. So take down another question. I have question function fx is equal to sin x divided by x minus 1 x minus 2. Now for this question we have to find out what is the domain of the question of the function. So see here, sin x is in numerator and sin x is actually, it is having its own curve which goes like this, right? It means what? On this axis we have x, everywhere x. I can go from minus infinite to plus infinite. I can go smoothly, I mean all the values I can pick and I can substitute here. But we have a problem is with denominator. I cannot substitute here x is equal to 1 and I cannot substitute here x is equal to 2, because if I do, then this total answer will start coming as negative, as a 0, and in the denominator 0 is not allowed. Means I can choose any number because of sin x, I can choose any number because of this bracket other than 1, I can choose any number other than 2. It means I can choose any number r, but I have to remove I have to remove 1 and 2 alone. See here, you may be knowing about this curly bracket from the previous lecture. Okay, so these two numbers I have to remove from the r, so this total will become your domain. Now let's solve one more question. If the same question I will give you like this, fx is equal to sin x divided by under root I am putting here x minus 1 x minus 2. Now see here, in the last question I had only one thing to bother. Because of these two people my denominator should not be 0, but because of the root I have one more thing for concern. This total answer should not come negative also. It means because of the root I have condition that x minus 1 and x minus 2, they should be more than or equal to 0, then only under root function will work. But this equal sign I am removing because the root is in denominator. So if I will remove this equal sign, then I will write like x minus 1 x minus 2 greater than 0. Okay, now when you have only greater sign or only less sign, in that case you should not use close interval. Okay, if you will be having any doubt, you can ask me now what I'm trying to say. Feel free and ask your doubts. See here, for this given inequality, this is known as inequality, I will draw my line number and on that I will draw my critical points. So this bracket is giving me critical point as x is equal to 1 and here x is equal to 2. What is critical point? When you are substituting x is equal to 1, x is equal to 2, then you are getting some numbers. Okay, that is 0. So for x is equal to 1 and 2, you are getting 0. So x is equal to 1 and 2 became your critical point. So 1 you put here and 2 you put here, and then below 1 you cross check all the numbers, pick any number and check whether you are getting greater than 0 or not. So I am putting a big number, suppose less than 1, 0 is also possible, correct? So put here 0, put here 0. So this is also negative, this is also negative, so answer is positive. It means I can pick this. It means any number below 1, it will satisfy the interval. How? You can choose any other number. For example, below 1 minus 5 is there. Okay, so substitute minus 5 here, minus 5 here. So this is also negative, this is also negative, means total answer multiply positive. So we are getting positive answer. It means this set is valid. So this set means what? From minus infinite, because this side you have minus infinite, this is plus infinite. So open interval minus infinite 2 comma 1. Okay, comma 1 open interval. So this set is valid. So automatically this will not be valid and this will be valid. You can check between 1 and 2. You choose any number, suppose 1.5. So substitute here 1.5. So this will be giving positive answer. But here you will be getting negative answer. So positive into negative. More than 0? No, less than 0. So that's why this interval you cannot choose. More than 2? You can choose. Take any number. Suppose 100. So 100 substitute here, positive answer. 100 substitute here, positive answer. So positive into positive, positive. So union 2 to infinite, open interval both side. So this became your domain for this question. Now let's practice some more question. See, exponential graph and logarithmic graph and all trigonometric graphs we have discussed in previous bridge course lectures. Okay, so I'm expecting that like you should revise those problems. Now we are going to discuss domain for exponential functions. Now see, if I am solving one question here or two question here, these questions will only give you ideas that how domain works and all the things. If you want to become a very good student or master in the particular topic, then you have to solve lot of numericals. Okay, so for that purpose on Google Drive already I have given everything. So go there, all the practice set is there, and you just solve this. Like for example, I'll try to show you here. Everything is there. I think something went wrong. Just a moment. Just a moment. Yeah. Okay, here I have to check. So if you go to bridge course, then you have all the DPPs. So in this DPP you can solve all the numericals. Oh sorry, I did not share the screen. That's why you guys are not able to see. Oh, in hurry I was just sharing the screen. Okay. Anyway, all the things are there on DPP. You just go and solve the numericals, and when you will solve the numericals for domain type of numericals, like right now whatever I'm teaching, you will be getting some difficulties and some doubts. So those doubts I will explain. Now let's solve this numerical, which is based on exponential problem. Very interesting problem. Suppose I am giving 10 power x plus 10 power y is equal to 10. Now see, in this function you don't have a proper function. It is like an equation, but I will mention here that my function is y is equal to fx, because if I will not mention y is equal to fx, then some other intelligent student can say that, sir, I have considered x is equal to fy as my function. In that case, situation will be somewhat different if I'll put negative sign here. But right now, whether you choose y is equal to fx or f is equal to symmetrical problem, so no problem. Okay, so I'm choosing y is equal to fx as my conventional method to choose any function. So how will you deal with 10 power x plus 10 power y is equal to 10? This question is very famous question when you prepare for IIT JEE or GATE exam. Very famous question. So first of all, we have to convert this equation so that it should look like y is equal to fx format. So can anyone tell me, advise, how can I go ahead? Anyone help me? Okay, I will explain. So you do one thing, because we are looking for y value. Yes, very good. Explain, I am listening. Explain. Yes, Harsh, continue Harsh, I am listening. Very good, Harsh. So I am approaching ahead. See, because I want to convert my question to look like this, y is equal to something fx. So very simple trick. This 10 power y you leave as it is. This part you bring right side. So 10 power y is equal to 10 minus 10 power x. Okay. Now you see, we can take log both side, and because 10 is here, 10 is here, 10 is here, so I will keep base 10 everywhere. It will help me. And you know, when we take log automatically, then we can keep base of our own choice. When I was teaching log, that time I explained these things with several numericals, several examples. So you take your y into log 10 is equal to log 10, bracket 10 minus 10 power x. Now here student can do a common mistake. Student can take this log separately and this log separately. I mean, student in hurry burry, student can take log 10 minus log 10x. No, we should not do like that. Everything in the right side we have to club together, and then you take log the way I am taking here. Now next, this log 10 I will divide like this, and I will apply the property of log. If you have log a divided by log b, then you can write this as log a base b. This property I will apply here. So this log 10, when I will divide here, this 10 I will write as a base here. Okay, so I can short out my step. So that base 10, you can see it is working now. What is next? Then I got my equation y is equal to fx format. Now it is looking like y is equal to fx, where f is your log function and this x means here. So now we can apply log property in this format. So 10 minus 10x should be greater than 0. This is your log condition from domain concept. Okay, then what is next? Okay. So now what I am going to do, this total thing I will split. This 10 power x I will send this side. So it will look like 10 minus 10 power x, this was greater than 0, so 10, simply this part I am putting right side. Okay, I hope it's very clear. Now you see, this part and this part I have to see exponentially, so I am going to put 1 here so that I can see the comparison. So of course, if this total thing is greater than this, then this 1 has to be greater than this x. So 1 has to be greater than this x. It means what? If you check the line number, so this is your 1. So this x has to be smaller than 1 always. Means this side. So this side values we have to take. So from minus infinite to this 1 values are valid. It means in open interval put minus infinite comma 1 and put open interval. That's all. This is your domain for the equation, right? Now I'll take very interesting problem again. Now we have separate question for domain. Fx is equal to log 1 plus x cube base 10. So how to tackle this question? See here solution. In front of log, whatever is given, that should be more than 0. So 1 plus x cube greater than 0. Now this 1 plus x cube, how will you break? So many students will go confused here itself. So for that, in bridge course program, I have taken polynomial as a chapter. There I have given all types of important formulas. With the help of that, you can break this. So when you will break this, 1 plus x and 1 minus x plus x square. And see, in that lecture series, I have given all the polynomials to break down. So from and practice questions are also there. So you practice and then you will be able to break like this, greater than 0. Then from here, one critical point I am getting from here. See, this is 1 plus x. I can also write x plus 1. Don't be confused. So this is giving me a critical point, x is equal to minus 1. Okay. And this I can write as x square minus x plus 1. So this will give me, like, in this, how will you think? See, x square minus 1 plus x. This will be positive always, no doubt, for any value of x. This is the trick. But how do you know this is the trick? If your coefficient of x square, which is 1, if this coefficient is positive, so of course this one is positive, and your discriminant is less than 0, means if you focus on the equation ax square plus bx plus c, in this equation, if your a means coefficient of x is more than 0 and your discriminant means b square minus 4ac, if this total guy is less than 0, then this value will always be greater than 0, means always positive. So this part, if you check by trick, then automatically it is positive. So we only have to think about this bracket. This bracket should be positive, then only the entire quantity will be more than 0. So x plus 1 should be positive. So for that you apply the concept of x plus 1 should be positive, means should be greater than 0. So x should be greater than minus 1. This one I am sending this side. So on line number, this is your minus 1. So your x value this side is valid. So finally you got your domain minus 1, 2 plus infinite. Open interval, open interval. Okay, this became your final answer. Now we'll practice one more question. So our next question is fx is equal to 1 by log 1 minus x base 10. Okay, I can extend this for some more x plus 2 also. Okay, now see, for this guy you have one condition, and you know that condition, x plus 2 should be more than equal to 0. It means on the line number, if you have minus 2 as your critical point, so this x should be more equal to minus 2. So from minus 2 you go this side, all the values are valid as your domain. So this we are getting from this part, but this part is also giving me some answer. This 1 minus x should be greater than 0, and one more concept is there. X should never be equal to 1. Why? Because if x will be equal to 1, then this total answer will become 0. In front of log 0 is. Okay, so meeting got over. So joining again. See here, for this particular thing we have to focus in such a way that this total thing should not be equal to 0. First thing, it means log 1 minus x base 10, this should not be equal to 0 because of denominator concept. So this is one condition we have to follow. Next condition, this 1 minus x should be more than 0. Why? Because it is in front of log, so log cannot be. Next, this total thing cannot give you 1. Why? Because if it will give you 1, this total thing, yes, if this total thing is giving you 1, then in front of log 1 will come, so 0 will come. So log 0 means total answer 0. So that part we have to cover from here. So this second condition also we have to follow. So now I am following the first condition. See, this 10 I can send to this 0. So 1 minus x is not equal to 10 power 0. So 10 power 0 is 1. So 1 minus x is equal to 1. So you take x this side and 1 this side. So 1 minus 1 is equal to x. So x is equal to 0. X is equal to 0 is not possible. It means, now next condition, from this you check out 1 greater than x. This x you send this side. So it means x should be less than 1. If I'll write this in proper way, x should be less than 1, correct? So now if you check the line number, so this is saying me any value more than minus 2 is valid. This is saying me x should not be equal to 0. So meanwhile somewhere here you have 0. So this 0 we have to leave. And this is saying me x should be less than 1. So somewhere here I have 1. So I cannot go more than 1. Before 1 only I have to stay. It means what? From this minus 2 to 1, all the values are valid excluding this 0. Clear? So how will I write? I will just erase this part, and I will mention here answer as. Now see, this minus 2 to 0 open interval union 0 to 1. This will be your final domain. Now let's discuss very important, extremely important And mind-blowing functions, they are modulus functions, absolute value functions. We used to call them absolute value functions. So y is equal to mod of x. What does it mean? Meaning is x can pick negative value also and positive value also, but this y is actually coming because of these two lines, and these two lines are modulus function. Modulus function means if my x value is -3, for example -3 Newton, and suppose I am saying y is equal to mod of x, so it means this y is looking only for the magnitude, only for the modulus. So y will come as 3. Okay, only 3. Means in mathematics, if you will write y is equal to mod of -3, then automatically it becomes 3, because this modulus function filters the sense, I mean minus sign, plus sign, direction, everything. It is only bothering about the modulus, like what is the exact value, the magnitude part only. Okay, so actually x can carry negative answer and positive answer, but y will only have the magnitude, and magnitude, if you see mathematically, it is always positive, right? So if you go for y is equal to mod of x, then on x-axis you can pick any value from positive to negative, from minus infinite to plus infinite, but on y-axis you will be having only positive numbers. So y is equal to mod of x, you have to break for two different intervals exactly at 0. So this side x is positive, this side x is negative. So it means what? Whenever modulus function is given, you have to check the critical point where it is being positive and negative, above that and below that. Like for example, if I'll choose y is equal to mod of x minus 1, and if I'll choose y is equal to mod of x plus 1, and this, in all the three cases you understand the graph. So first of all, y is equal to mod of x graph, you check, it will be like this. Why will it be like this? Because I have to define y will be plus x if for, now see, I am saying y is plus x, so I have to mention for x is equal to greater or equal to 0. Then I should say y will be, I mean this mod of x will become minus x for x less than 0. So for these two conditions, I will consider this as a different graph and this as a different graph. So that's why this line is y is equal to plus x line, and this line is y is equal to minus x line. Done. That's why this total V shape is known as y is equal to mod of x graph. Okay, now see, just keep in mind, exactly at the sharp point, function is never differentiable. Function is not differentiable at sharp point in any graph. Now how will you tackle the same thing for if I draw y is equal to mod of x minus 1? So in this case, what is your critical point? Your critical point is x is equal to 1. So x is equal to 1 is here. So if your answer is less than x is equal to 1 or more than x is equal to 1, then how your graph will behave? No doubt, draw like this. So just an example, if you will put any number which is less than 1, for example you put 0.5, so add this 0.5, what is the answer? 0.5, your answer is this. Clear? And this is your 1. Now if you go like this, there is one more value of x at which you have same answer. Can you guess what is that value? You can see from here. For if you are substituting here x is equal to 0.5, then you are getting y is equal to 0.5. If you will substitute x is equal to 1.5 also, then also you will be getting 0.5. You just check here, put y is equal to mod of 0.5 minus 1, or you go for y is equal to 1.5 minus 1. In this case also you are getting y is equal to 0.5. Technically you should get minus answer, but because of this modulus function you are getting 0.5. And here also you are getting y is equal to 0.5. It is automatically positive, and of course modulus function is also there, but it is already positive, so modulus function is there or not does not matter. So that's why this is your 1.5, x is equal to 1.5. Clear? So this is your x-axis, this is your y-axis. So here is one trick. If you are subtracting any number, so you shift your graph in x direction. But if you are adding any number, then you shift your graph in this direction. I mean to say, if you want to draw y is equal to mod of x, then you draw exactly from mid. If you want to draw y is equal to mod of x minus 1, then you shift the graph to the right side. Right side means here you have y is equal to this. If you have y is equal to mod of x plus 1, in that case you shift your graph to minus 1, like here. This will be your graph. It's clear? Now based on this you can see what is your range and what is your domain. Range means, and domain means, this side values also you can carry, this side values also you can carry. It means from minus infinite to plus infinite, everything you can carry. In this case also your domain is from minus infinite to plus infinite, everything. So answer is R, answer is R, answer is R for your domain. This is how you can judge. Okay, these functions we will see again when we'll be dealing with limits, continuity and differentiability. Okay, these are very important logic. Limit, continuity and differentiability. So we are going to see them also, but not in today's lecture. I mean tonight's lecture. This is enough for tonight. We'll solve one more numerical for absolute function, I mean, or you say this domain type function, and we will check what is the like magnitude, I mean what is the domain. See one more question here. Suppose you have mod of x minus 3 plus mod of 4 minus x is equal to 1. Now this became equation. Now for this equation I want to check where this will lie, where the x value will lie. So one trick is very simple. This x minus 3 we have to break at the point x is equal to 3. This 4 minus x we have to break at x is equal to 4. So we got two critical points. So this here I will put x is equal to 3, and here I will put x is equal to 4. Now you see the trick. Now understand one trick by using the formula. You can, if you have x plus y anywhere, this will be exactly equal to mod of x plus mod of y, if there is a condition, if x into y is greater is equal to 0. With this condition I can approach. Now how many conditions we have like this? Sub 5 to 7 very good conditions are there. I can give you PDF for this condition, so that those PDFs will, I mean those conditions will help you to solve other numericals, and other numericals also I will give you. But no need to solve all the numericals. Whatever numericals I will give you with tick on the drive, only those numericals you solve, and for doubt purpose you ask. So I will check mod of x plus y. I can split as mod of x plus mod of y, but we have condition. The condition is x into y should be greater than 0. So how can I test this? Mod of x plus mod of y is equal to mod of x plus y I can write. It means I will consider this as one function and this as another function. Then I am going to combine them. Okay. Let's do multiplication and check. Are we getting 1 here? Try to understand. If this mod and this mod, you will go through this formula, then are you getting 1? Yes, the question itself is saying you are getting 1. And if you are getting 1, it means you should follow x plus x into y greater is equal to 0. Right? You just try. Mod of x means this entire value. Mod of y means this entire value. And it is coming as mod of x plus y. Let's check. So I'm going to add. This x value is x minus 3, x minus 3. This y value is 4 minus x, 4 minus x. X and x got over, minus 3 and 4 we got 1. So mod of 1 means 1. So yes, we are getting 1. Already question itself was 1. It means then I can think on this concept. If this is satisfied, then I can go for x into y greater than 0. So for that, my x value was x minus 3, y value was 4 minus x. This is 4. 4 minus x greater is equal to 0. Okay. Now, I want to write this in this format, x minus 3 and x minus 4 greater is equal to 0. But if you are changing this pattern, then you should take minus sign common. So that minus sign I am keeping here. Now, to compensate this minus sign, I will change this. I mean this entire thing I will take right side. So automatically this minus sign will become positive. So this sign I am leaving as it is. This total part I am shifting to the right side. So 0 will appear here, and here x minus 3, x minus 4 will come. I can do this directly, but because it is like your basic class, so that's why I am doing like this, like kids. So see. Now this complete part I can write like psychologically. This total thing is less is equal to 0. So I am writing like bracket x minus 3. Same thing I am writing less is equal to 0. Actually, these kind of formats we used to feel comfortable. That's why I'm writing in this way. Now I'm erasing this part. Okay, you understand what part I have erased, right? So now for this you draw your line. So on the line you have one critical point here which is 3, one critical point here which is 4. So you choose any number which is less than 3. Any number which is less than 3. You can choose 0 also. So put here 0, put here 0. Negative and negative. Negative and negative. Multiplication is coming positive. So no, we don't want positive. Why? We are not looking for that number who is giving a positive answer. We are looking, our answer should be less than 0. So I told you that if this interval will not satisfy, this interval will satisfy, this will not satisfy again. So automatically for cross check, you can choose any number. And now see here, because equal to sign is there, equal sign is there, equal sign is there. So this time 3 to 4 interval you will take, 3 to 4 interval, and you will choose close interval because equal sign was there. So this became your domain for this question. Okay, that's all. Now all the homeworks and all from Drive you do, and whatever doubts you have, you ask now. Class over for tonight.